Hi everyone, I am Kiranmai. Welcome to my channel Chemistry Tutorials by Kiranmai. And today's topic is discovery of subatomic particles. In the last video, we discussed about the introduction to the chapter atomic structure. And today's topic is discovery of subatomic particles. At the end of 19th century and beginning of 20th century, scientists discovered the subatomic particles. When scientists are conducting experiments such as passing electricity through gases, the concept of subatomic particles originated. First, let's discuss about the discovery of electron. Discovery of electron. In 1830, Michael Faraday showed if electricity is passed through solution of electrolyte, chemical reaction occur at electrodes result in liberation and deposition of matter at electrode. See, consider an electrolytic cell means a, a container or a vessel in which there are two electrodes, positive electrode and negative electrode, containing a solution of electrolyte. Electrolyte means a substance which produce electricity conducting solution when dissolved in polar solvent such as water. Means, for example, if you take NaCl and add to the solution polar solvent such as water, generally it produces ions Na plus and Cl minus ions. These ions, when electricity is passed, conducts electricity. As we all know that charged particles conduct electricity. So the solution of electrolyte means it conducts electricity. We are passing current or electricity through this solution. And when electricity is passed through this solution, some sort of chemical reactions occur in the electrolyte and result in the liberation or deposition of matter at electrodes, that is at cathode and anode. See, when the solution is there, electrolytic solution is there, there are particles Na plus ions and Cl minus ions, for example, are there. But when electricity is passed, we are observing some chemical reactions and liberation and deposition of matter. This result suggests that there is a particulate nature of electricity. That means that something is there in electricity which leads to the chemical reaction and result in liberation and deposition of matter at electrodes. So this particulate nature of electricity is observed first by the scientist Michael Faraday. Based on his observation, he also proposed Faraday's laws, which we later discussed in chapter electrochemistry. At present, for today's lesson, just keep in mind that due to these experiments, Faraday got an idea that electricity has a particulate nature. Later, in mid 1850, many scientists, including Faraday, began to study electric discharge in partially evacuated tubes. Partially evacuated tubes means by using vacuum pump we are removing air from a closed discharge tube so that the pressure gets reduced. Under these conditions, electric discharge in partially evacuated tubes is studied. This is a diagrammatic representation of partially evacuated tubes. So in this tube we can see the two metal electrodes. These are the thin metal pieces which are connected to a battery. One acts as cathode and another one acts as anode. When electric discharge is passed through, when the electricity is passed through these tubes, some sort of discharge or some sort of rays is observed which are traveling from cathode to anode. Cathode to anode. As the rays are coming from cathode, these rays are called cathode rays. So these discharge tubes are also known as cathode ray discharge tubes. So in these cathode ray discharge tubes, cathode rays are produced when electricity is passed through them. But the compulsory condition is that when these cathode rays are emitted only when it is carried out at low vapor pressure, low pressure and when high voltage is applied. So when at low pressure and high voltage electricity is passed through a gas, then cathode rays are emitted from the cathode and it moves towards anode. And the proof for this experiment is that we cannot see these cathode rays. Unless we see, we cannot confirm the emission. So scientists applied a fluorescent coating or phosphorescent coating at the anode side and observe that one. So this is cathode and this is anode. In anode they made a small hole and back of the anode they coated it with phosphorescent material. Zinc sulfide. Phosphorescent material, zinc sulfide. These phosphorescent or fluorescent material have a capacity to emit a light. That is, we all know that electrons get excited from lower energy level to higher energy level, and then while coming back from higher energy level to lower energy level, they emit a light, energy in the form of light. So okay, these phosphorescent materials, just like a radium material, in dark, when the radium material is kept in light and then when we place these radium material in dark, we can observe some sort of light coming from the radium material. No, in the same way, these fluorescent or phosphorescent materials, when hit by light ray, after some time it emits light. So when cathode rays or when cathode rays coming from cathode reach anode through this hole, it touches phosphorescent material. When it touches the phosphorescent material, a spark of light is observed. So, these bright spots indicate that some particles or some rays are coming from cathode and it is touching the phosphorescent material and giving the bright spot. So, if the particle is coming from the cathode, it must be a negatively charged one. Why? Because as the cathode is negatively charged one, it repels the negative charge, and at anode, as it is positively charged, attracts these negative charge. So the cathode rays contain the particles which are negative in charge. So these experiments led to the discovery of electron. We can summarize these results as cathode rays start from cathode to anode. So starts from cathode to anode. These rays themselves are not visible. We cannot see these rays, but we can observe with the help of certain kind of materials such as zinc sulfide, which glow when hit by cathode rays. So not visible but can observed can be observed by fluorescent or phosphorescent materials. Next, in the absence of electric field, these are negatively charged particles. In the absence of electric field, they travel in straight line. So when electricity is there, negatively charged particles get attracted to positive electrode. But in the absence of electric field, means the emitted cathode rays, when kept in electric field, that is between the positive and negative electrode, they get deviated. But in the absence of electric field, they travel in straight lines. And next one, in the presence of electric field and magnetic field, cathode rays are similar to the behavior of negatively charged particles. So here you can see these cathode rays are similar to a negatively charged particles. So they are moving towards anode. These suggest that these particles or cathode ray particles are negatively charged particles. And these particles do not depend upon, that is, cathode ray particles do not depend upon the material of electrode and nature of gas. See, these cathode rays are coming from cathode, but these cathode rays nature doesn't depend upon the nature of cathode. That is, where, whether you take a copper electrode or zinc electrode, the rays produced by these electrodes or the rays coming from these electrodes will have the same characteristics. That is, it doesn't depend upon the nature of the material of the electrode, and it also doesn't depend upon nature of gas. Here the nature of gas means the gas present in the cathode ray discharge tube. These gas doesn't define the characteristics of these cathode rays, so it is independent of the nature of material of electrode and the nature of gas. This suggests that there is some particle in all the matter that is negatively charged one. We can conclude that electrons are, that is these particles, we are naming it as electrons. These electrons are basic constituent of all atoms. Electron is basic constituent of all the atoms. Basic constituent of all the atoms. So here, when the electricity is passed through the gas at very low pressure and high voltage current is applied, then we can observe the discharge from the cathode. Very importantly, please remember that these cathode rays are not the current or electricity we are passing. These are the rays emitted from the cathode, and these cathode rays are moving from cathode to anode. This doesn't depend upon the nature of the electrode and the nature of gas. It is originating from cathode, but it doesn't depend upon the nature of the cathode. So it is a universal one. So we can say that these particles, we are naming it as electron, is basic constituent of all the atoms. Next one, charge to mass ratio of electron. Charge to mass ratio of electron. So scientists discovered there is a subatomic particle called electron, which is negatively charged, present in the atom. And then later in 1897, J.J. Thomson measured the ratio of charge and charge to the mass of the electron, that is charge E to the mass of the electron. Here E is charge and ME is mass of the electron. See, charge is, we can say that it is a negatively charged one, but what is its capacity? How much charge that electron contain is not known, and what is the mass of the electron is not known at that time. So Thomson made a cathode ray tube modified by applying a magnetic and electric field. See here, it is a cathode ray tube which contain a cathode and an anode, in which small hole is there. Negative charged one, and it is a positively charged one. Cathode, and it is anode. Vacuum pump is there, so that the gas gets evacuated, creating very low pressure and high voltage is applied. So at low pressure and high voltage, when cathode rays is produced from cathode and it moves towards anode. So this is the path of cathode rays. So for this path, J.J. Thomson applied electric field and magnetic field perpendicularly. So this one is the path of cathode rays, that is, it contains electrons. This one, this is this one, the path of cathode rays. For this one, he applied electric field perpendicular 90 degrees, perpendicular electric field, and magnetic field which is coming out from paper. This is path of cathode rays, and this is perpendicular. You can see perpendicular magnetic field. See here like this. Path of electrons, positive charge and then negative charge, electric field 90 degrees, and we can see this one coming out from paper 90 degrees, magnetic field north pole, south pole. So like in electromagnetic radiation, when the electric field and magnetic field is applied perpendicular to the path of the cathodes, he observed this one. When the electric field is applied, no magnetic field, when electric field is applied, electrons get deviated from their path and hit, let's say, at the point A. When the magnetic field is applied, no electric field, when magnetic field is applied, then the electrons deviates from its path and hit at this point, let's say C. And when carefully electric field and magnetic field is balanced, then the electrons move in their own path and hit at the point B. It's very similar to the absence of electric field and magnetic field. So when carefully balanced the electric field and magnetic field, we get the same result, that is, the cathode rays or electrons travel in straight line and hit at the point B. Thomson argued that amount of deviation, this deviation, that is electric field at gets when electric field is applied, it gets deviated and hit at point A, and when magnetic field is applied, it gets deviated and hit at point C. These deviations of particles or electrons from electric and magnetic field depends upon, first one, magnitude of negative charge. negative charge on the particle. See, when it is more negative, that is greater the magnitude, greater will be the deviation. Greater magnitude, greater is the interaction and greater is the deviation. And it also depends upon mass of the particle. Lighter the mass, greater will be the deflection. Lighter the particle, greater the deflection. And third one, it also depends upon the strength of electric field or magnetic field. So he argued that amount of deviation of particle from electric field or magnetic field depends upon magnitude of negative charge, mass of the particle, strength of electric field or magnetic field. By these experiments, he was able to determine the value of E by me, that is charge of the electron by mass of the electron, as 1.7588820 into 10 power 11 coulombs per kgs. See, this here E is charge of electron and me is mass of the electrons. Charge is measured in coulombs and mass is measured in kgs, and it will have a negative charge. Negative charge. Next one, charge on the electron. R.A. Millikan in the year 1906, through his experiment Millikan's oil drop method, discovered charge on the electron. Oil drop method. This is the rough diagram I am drawing of the apparatus used in oil drop method. These apparatus consists of atomizer, atomizer is nothing but a simple apparatus which is similar to a scent or perfume bottle. With the help of this atomizer, oil is sprayed in the form of mist. That is a tiny droplets of oil. It has an electric condenser. It have a small hole on the positive end, and through this hole oil droplets are entered into this chamber. Electrical condenser is an electrical device which have a capacity to store electric charge. It also contains a telescope through which we can view oil droplet, and it is also connected to a source of X-ray. This is a simple diagram of this oil drop method. So when the X-ray is passed through this chamber, the gas present in this chamber gets ionized. Why? Because X-rays are not charged run, but they have the capacity to remove electrons from the atoms or molecules. So when X-rays are passed through the gas, these gas molecules or atoms gets ionized. Gets ionized means they from them the electrons get discharged, and then they are converted into a positively charged ions, and then it releases the electrons. These electrons gets deposited on these oil droplets, and then the oil droplets get charged. So these oil droplets are negatively charged. So these negatively charged oil droplets falling from this one, basically it is not charged. When it enters into this chamber, gets charged. So again it moves towards the positively charged one. The movement, this rate of fall of oil droplets means it is moving upwards, or it is moving downwards, or it is standing still. These conditions are observed through the telescope. By measuring the rate of fall of these oil droplets inside the chamber, that is, it is getting slower, or it is getting faster, or it is standing still, depends upon the polarity and strength of the voltage. It depends upon the droplets charge on the droplets, and here we are applying current, that is electricity. The voltage applied here, the strength of voltage alter the speed of the oil droplets. By carefully measuring the effects of electric field strength on the motion of oil droplets, Millikan concluded that magnitude of electric charge, see here, magnitude of electric charge, that is the negative charge present on the oil droplet, that is due to the electrons on the oil droplets, is always integral multiple of one whole number. See, magnitude of electric charge, magnitude of electric charge on oil droplet is an integral multiple of, let it be Q, it is an integral multiple of electric charge E. That is Q equal to N E. Here N is a whole number. N is equal to 1, 2, 3 and so on. So this electric charge, magnitude of electric charge is the product of, or it is always the integral multiple of electric charge. I will discuss one example and then we'll come back to this point. Suppose it is a box of chocolates and they are packed in pairs. There are 2 chocolates in each packet and there are so many such packets in this box. And you and your classmates are asked to pick some packets of this one of your choice. Suppose there are 5 students A, B, C, D, E. They are asked to pick chocolates of their own choice. A picked 2 packets, B picked 4, C picked only 1, D picked 3 packets and E picked 2 packets. So A have 2 packets of chocolates and in each packet they have 2 chocolates. Means overall A have 4 chocolates, B have 4 packets and each packet B have 2 chocolates. Means 4 into 2, 8. C have 2 chocolates, D have 6, E have 4. Means A have 4 chocolates, B have 8 chocolates, C have 2 chocolates, D have 6 chocolates, E have 4 chocolates. 4, 8, 2, 6, 4. And this one can be written as the products of 2. That is, these are all the factors of 2. So it can be written as multiples of 2. So 4. 2 into 2, 8. 4 into 2, 2. 1 into 2, 6. 3 into 2, 4. 2 into 2. Here 2 is same. That is the number of chocolates in each packet. And this is random. It's a whole number. Same thing. The oil droplets are carrying a charge, that is Q, means it's 4, 8, 2, 6, 4. This is, let's think it's a Q, and Q is equal to N into E. E is common for all, that is 2. N can be 2 or 4 or 1 or 3 or 2, but 2 is common. Means magnitude of electric charge on oil droplet is a integral multiple of electric charge, whether it can be 4, 8, 2, 6 or something, but it's an integral multiple of 2, that is electric charge. This one is discovered by Millikan, and the charge of the electron E is equal to 1.6 into 10 power minus 19 coulombs. This was discovered by Millikan, and present value, accurate value is 1.602176 into 10 power minus 19 coulombs. This is the charge of electron. As electron is negatively charged one, so electron's charge is negatively charged one. The charge is minus 1.602176 into 10 power minus 19 coulombs. Okay. Hope you understand this example. And if you have doubts, please ping me. I will explain you again. Okay. Millikan discovered the charge of the electron. Earlier, Thomson discovered the ratio of charge and mass of the electron. Thomson charge by mass of the electron as 1.758820 into 10 power 11 coulombs per kgs. And then Millikan discovered the charge of the electron E. What is the E value? Minus 1.602176 into 10 power minus 19 coulombs. So, if we know the ratio and the charge, it is a charge by mass ratio, and it is the charge value. So from these two we can calculate the mass of the electron. See here, if we divide charge by this ratio, charge, that is E by ratio, charge by mass ratio, we get mass of electron. See, charge of the electron by charge by mass of the electron is equal to charge of the electron into, reciprocate this one, mass of the electron by charge. This is equal to this. So E gets cancelled, we get mass of the electron. So similarly, charge of the electron means E means 1.758820 into 10 power 11, it's 11 coulomb per kgs. This is a charge by mass ratio, and charge of the electron is minus 1.602176 into 10 power minus 19 coulombs. If we calculate this one, we get mass of the electron equal to 9.1094 into 10 power minus 31 kgs. This is mass of the, here also we get negative charge as we have charge of the electron. Okay, negative gets cancelled and we get this one, mass of the electron. This is the discovery of electron, mass of the electron, charge of the electron. And later we discuss about the we discuss about the discovery of proton. Similar to the cathode ray tube, scientists modified this cathode ray tube and carried out electric discharge, and this led to the discovery of special rays called canal rays. We all know that in the cathode ray discharge tube, during low pressure and high voltage, when electricity is passed through this chamber, cathode rays are formed and then it moved towards anode. In this modified experiments, modified cathode ray tube led to the discovery of canal rays. These canal rays are the positively charged particles which are moving towards negatively charged cathode. Keep in mind that cathode rays are originated from the cathode, but these canal rays are not originated from anode, and these rays are moved towards cathode, means they are positively charged. And these rays, cathode rays, characteristics are, unlike cathode rays, mass of these canal particles of these canal rays, these positively charged canal rays mass depend on nature of gas present in this cathode ray tube. See, these are not originated from anodes. These are the rays, positively charged rays, and these nature depend upon the nature of gas present in cathode ray tube. If you take one type of gas, you will get one type of canal rays. If you take another gas, if you get another canal rays. So it depends upon the nature of gas. And charge by mass ratio of particles present in canal rays depends on gas from which these originate. Depend on nature of gas. So see, positively charged particles in canal rays depends upon the nature of gas present in the cathode ray tube. Simply positively charged gaseous ions. These are the simply positively charged gaseous ions, and their charge by mass ratio also depends upon the nature of gas. Some positively charged particles carry multiple of fundamental unit of electric charge. That is, some charged particles may have unipositive, some may be dipositive, like that. It is not constant. Multiple of fundamental unit of electric charge. That is, it may be a unipositive ion, it may be a dipositive ion, or it may be a tripositive ion, like that. And then behavior of these particles in magnetic and electric field. See, when cathode rays are passed, its behavior alters when electric field and magnetic field are applied. Like that one only, these particles also gets altered. Their path will get deviated when electric and magnetic field are applied, but it will be in opposite direction to that of cathode rays. That is, opposite to cathode rays. So these cathode rays have negative ions, negative charged particles. So not ions, negatively charged particles. When canal rays have the behavior opposite to cathode rays, it indicates that the canal rays are positively charged rays. So there are some particles in matter, that is, some particles in atom which are positively charged, and the smallest positive ion is obtained from hydrogen gas. hydrogen gas. We named them and then was named them as proton. So the positive ion obtained from hydrogen gas is named as proton. So when any gas produced when any gas placed in cathode ray tube and electricity is passed, the gas emits some sort of rays under low pressure and high voltage, and it gets moved towards cathode and the observed rays or canal rays. These canal rays, as it is moving towards cathode, are positive charged. These positive charge depends upon the nature of gas present in cathode ray tube, and its charge by mass ratio also depends upon the nature of gas. And these charged particles carry multiples of fundamental unit, that is they may be unipositive or dipositive like that, and their behavior is opposite to that of cathode rays. This all suggests that they are the positively charged ions. And then the smallest ion produced from hydrogen gas, and it is named as proton. Next one, discovery of neutron. Chadwick in the year 1932 discovered neutron. He is doing the experiments on the time. He took a thin sheet of beryllium and then bombarded with alpha particles. Alpha particles are nothing but the particles containing 2 protons and 2 neutrons. These are emitted during radioactive decay. So during radioactive decay, alpha particles are emitted. These are used as source, and it is made to strike beryllium metal. And then the rays emitted from it showed 2 types of particles, protons, which are positive charged, and there are also some particles which are not charged but their mass is slightly greater than proton, and then Chadwick named them as neutrons. This is the discovery of neutron. So by the end of 19th century and starting of 20th century, scientists discovered proton, neutron and electron. And then the scientists made models explaining the structure of atom. Let's discuss about the structure of atom in next video. If you have any doubts in this video, please let me know. I will clarify your doubts. If you like the content of this video, please like the video and share to your friends who are studying with you. Thank you.